Good evening, everyone. Hello. Good evening, everyone.
Some people are in the lobby.
Those who are in the lobby, I think they are in. Now,
Continue.
today
Finish.
we are going to talk about mathematics for statistics, and basically we are going to talk about complex numbers. First of all, before we start, I'll be your mathematics for statistics teacher, and some of the objectives of this lesson is, by the end of the lesson, you as the learner, you should be able to define what a complex number is, represent a complex number using an Argand diagram, perform operations involving complex numbers such as addition, subtraction, multiplication, and division. Are we together? Hello?
Yes.
Are we together? Hello? Now, I would like to call the roll call. Vivian, are you in? Joseph Oseda? Adera Opio?
Very present.
Now, let us go straight to the topic of the day, as we had stated the objectives up there. Now, what is a complex number? Any trial, Joseph? Any trial on complex numbers definition? Who can define for us a complex number? Yes? I can't hear you. Okay. That's a good trial. Anyone? Next person, Oseda, can you try what a complex number is? Hello? Now, this is the definition of what a complex number is. A complex number refers to any number that can be expressed in the form of a plus ib, where a and b are real numbers and I is an imaginary number called the iota. The set of complex numbers is denoted by letter C, capital. And I in complex number is equivalent to the root of -1, or I squared is equals to -1. Now, who can give us any example of a complex number? Vivian? Yes, an example of a complex number.
9.
Yes. 9 plus?
9 plus.
Yes, that is a good trial. Another one?
Right?
Eh?
Right.
Apio, can you be a bit audible?
I'm saying another example is 4 minus 3i.
That is very true. Correct. Vivian?
19 and
Thank you. Now, let us go to the Argand diagram. In your previous class, maybe you have talked about the Cartesian plane and how you can represent the Cartesian coordinates on a Cartesian plane. Now, in complex numbers, the complex numbers are represented diagrammatically on an Argand plane using the Argand diagram. So, who can define for us what an Argand diagram is? Joseph.
Yeah.
Thank you. So the Argand diagram is basically similar to the Cartesian plane, but now the real number of the x-axis of the Cartesian plane will represent the real number in the complex plane, while the y-axis in the Cartesian plane will represent the imaginary number in the complex plane. Now, the diagram below shows what the Argand diagram is all about. I think everyone can see it. Vivian, are you able to see it? Vivian? Hello? Joseph? Joseph, are you able to see it? Martin? Martin, are you in class? Now, we want us to move to the next subtopic about operations involving complex numbers, and we shall start by addition of complex numbers. Now, given two complex numbers, a plus ib and c plus id, for us to perform the addition on them, we shall group the real numbers together, while the imaginary numbers, we shall also pair them together. So, for example, given a plus ib is a complex number added to c plus id. The real part of the complex numbers are a and c, while the imaginary part of the complex numbers are ib and id. So when we are going to add, we shall add a plus c to form the real number part of that complex number, while b plus d shall form the imaginary part of the complex number. Now, let us have a real example. As you can see above, 20i added to 30i plus 5 shall give us what? Joseph, in 20i, that is a number on its own, and 30i plus 5 is also a number. What is the real number? What is the real number on the 20 plus I? Yes, because 20 plus I is the imaginary number.
The real number
what
of the
will
20
be
plus I.
Yes.
Add 20 plus 30.
Okay, if you study about the commutative property of numbers, there is no change when you have 20 plus I. It's like 0 plus 20i, so the real number should be 0. Are we together?
Yes.
Yes, so it will be, and the second part is 5 is the real number. Now what will be the answer, Vivian? What will be the answer for that operation? 20i plus 30i plus 5. If you group them, what will you get? Joseph?
When the final answer?
Huh?
It's 5 plus.
That is very good. Let us move to subtraction. Now we want to perform subtraction of complex numbers. Just like our previous example, given a plus ib and c plus di, we want to subtract c plus id from a plus ib. Now the real part, first of all, we shall remove the bracket by multiplying the minus with what is in our second bracket to give us a plus ib minus c minus id. Are we together? So,
Yes.
so in general, whatever we have on the right hand side is the general expression for the subtraction involving complex numbers. Now, given a real example, 2 plus 3i less 4 minus 6i, what shall we get? The real parts include
2 and negative.
2 and
2 and negative.
so 2 and negative 4. 2 minus 4 gives us what?
Negative 2.
Correct. And the imaginary part of the complex numbers are 3i,
3i plus 6i.
giving us what?
Giving us 9i.
Thank you very much. So the whole operation will be what? What will be the whole answer? Thank you very much. Let us go to multiplication.
Negative 2i.
Now for multiplication of complex numbers, we can write the expression a plus ib product of c plus id to be equivalent to ac minus bd in bracket plus I into AD plus BC. I hope up to now you understand what I is. Vivian, what is I? For a reminder, so that we can move together. What is I?
I is the complex,
I
the complex number.
Thank you. Now, you remember I said I refers to iota, or iota, and its value is equivalent to the root of negative 1, or I squared is equals to negative 1. Now, for example, given 2 plus 3i into 4 plus 6i, what shall we get?
18 I.
Can you move stepwise? It shall be what? 2 into 4 plus
can I
6i?
try?
Yes, Sophia.
I think the first real number multiplies everything the other complex number,
Sure.
and also the imaginary number of the first one multiplies all the terms in the second complex number. So we'll have 2 into 4 plus 6i plus 3i into 4 plus 6i.
Thank you. To give us what as the final answer?
Will give us negative 18 plus 24i.
Thank you very much. Let us move to division of complex numbers. Now, given to divide a complex number a plus ib by c plus id, first of all, for those of you who did SATs, have you ever come across the topic called SATs before?
Yes.
Yes? How are we?
Sad was making.
Huh?
Sad was sad.
So, did you do SATs?
Yes.
So, how are you performing operations involving division of SATs?
You apply conjugate.
The conjugate. Which conjugate? The conjugate of what?
The denominator.
Of the denominator. What is a denominator?
But the denominator is the lower value.
Given a over b, a represents what?
Numerator.
And b.
Numerator.
So when we are going to perform the quotient, we shall multiply by the conjugate of the denominator. So given a plus ib over C plus DI. What will be the conjugate of C plus DI?
C minus DI.
And if we add C minus DI, what will be the conjugate?
C plus DI.
Thank you very much. So I think you can follow the procedure, and you shall get the real number and the imaginary part of the complex number. Are we together?
Yep.
And now, given the real example, 3 plus 4i divided by 8 minus 2i, what is the denominator in that expression?
Denominator is 8 minus 2i.
So what will be the conjugate, Vivian?
8 plus 2i. 8 plus 2i.
Thank you. So why do we multiply by the conjugate?
To do away with the imaginary part
In the?
in the denominator.
Thank you very much. Now, if you perform that operation, you will end up having what? 4 over 17 plus 19 over 34i. So what will be the real number?
The real number is 4 over 17.
And the imaginary part?
19 over 34.
Okay. So who can summarize for us whatever we've learned today? In brief.
Okay.
Mm.
How to do some more.
There?
How to add, subtract, divide, and multiply complex numbers.
Thank you. Another one?
How to represent a complex number in a Argand diagram.
And you all know what an Argand diagram is.
Yes, it's just like a cartesian.
Thank you very much. And I said the I squared is equivalent to what?
What? Can you repeat?
I squared, the iota.
Yes?
-1.
Negative 1.
Thank you much. Now, before we end the class, there are some assignments I would like us to do, and your class rep shall select to bring for marking. Okay, are you able to see them?
Yes.
The first one is yes.
Plus. In bracket.
Yes. The next one,
6 plus 3i.
yes.
6 plus 3i minus 10 plus 8i.
So which operation is that?
Subtraction.
The next one,
4 plus 2 in bracket 4 minus 2.
which operation is that?
Multiplication.
Which is also the same as the product of the complex number, isn't it? Then the last one,
We have into bracket divide by.
so that is which operation?